Hi guys, welcome to my channel. Today we have another video on insertion sort. So this is the question 3 of A to Z series. We will be covering today insertion sort. So let's see about the problem. So the problem statement here says we are given an integer array of size n and we have to sort this array using insertion sort recursively. So we will see how the insertion sort works and how we can do it. So guys, firstly we will see the logic of insertion sort and how it works. So insertion sort basically works like we have a pack of cards and we want to sort the pack of cards. So let's say we have a few numbers and the numbers are 5, 4, 0, 1, 2, and now we want to sort them using the insertion sort logic. So what this logic basically says that we can assume a part of these numbers as sorted and a part of them as unsorted. So we can break them into sorted and unsorted. So first element by default we can take into the sorted list. So it is 5 and the rest all of them are unsorted. Now we can take the first unsorted element, that is 4, and we can put it into the correct position of the sorted list. So the 5 will come after 4 and then we will see, okay, the 5 is bigger than the 4, so we will swap this by one place and it will become 4, 5, and the unsorted will remain 0, 1 and 2. So in this and for the next number we have 0, so we will keep 0 like 4, 5, 0. So the 0 again is smaller than 5, so we will swipe it one place. It will become 4, 0, 5. Again for 0 we have 4, so 4 is again bigger than 0, so it will again have a swipe. It will become 0, 4 and 5. Now we have 1 and 2 in the sorted part. So now again we will take the first element of unsorted and keep it the last of unsorted. It will become 0, 4, 5, 1. Now if we check 5 and 1, we need to swap them. So it will become 0, 4, 1, 5. Again we see, so 1 is less than 4. Again we need to swap it. So it's 0, 1, 4 and 5. And now we have 2 in the unsorted list. So for 2, we insert the 2 at the end of the sorted list and put it to the right position. So it becomes 0, 4, 5, 2. Then we will keep on swapping it. It will become 0, 4, 2, 5. And it requires one more swap. So it will become 0, 2, 4, 5. So the basic logic behind the insertion sort is from the sorted array, we take the first element and try to keep it into the sorted array. So every time we keep the top element from the unsorted and we keep it into the sorted array at its correct position. One more example we can see, if we have the array like 6, 5, 4, 7, 8. Okay, so our we will take the first element as sorted, because if there is one element we cannot say it is unsorted. So this is the sorted part and this is the unsorted part. So we will keep 6 here and 5, 4, 7 and 8 here. Now we have 5, so 5 will come after this and we will see that 5 is less than 6, so it will swap one place to the left. It will become 5, 6. Now we'll have the second element, that is 4. Okay, so now the 6 is again greater than 4, so we need to swap it. It will become 5, 4 and 6. Again we see we need to swap it. The 5 is greater than 4, so it becomes 4, 5 and 6. Now we have 7, that should come at the end, so it will become 4, 5, 6 and 7. Then we have the next element as 8 and it will become 4, 6, 7 and 8. And by this we can see that the sorted array is 4, 5, 6, 7, 8. So we can see the time and space complexity. So for every element of the array A, let's say there are n elements. So for every n element in the array, we need to check all the elements in the sorted array. So this is the worst case scenario. So big O will be O of n square here, and time complexity will be, it will be constant O of 1, because there is no extra space that we are using here. Now we'll see the code and how the code works. So guys, here we can see our code of insertion sort. So we will try to understand the code. So we have an outer loop which will basically run from 1 to the last of the array, and this is the unsorted part. Okay. Now the inner loop will run from the first element of the unsorted to the first element of the sorted array from backwards, and every time we will compare if the unsorted part of the array is less than the sorted part, then we need to swipe it. Otherwise, if at one place also we see the condition like the sorted part is now less than our unsorted part, then we can stop the loop here. We don't need to cover the loop, because if one element of the sorted part is less than the unsorted part, then the left to the elements all will be less, so we don't need to check all of them. And this is how we can try to see the code. Yeah, and let's submit the code. I'll also give a link of this question in the description, so you can practice it from there.